Hello friends, welcome to Kavita's classroom. So today's topic in hand is very wonderful topic because it's liked by the students, easy to understand as well and of use to you as well. Right? So this is called consumer equilibrium through indifference curve analysis. Before proceeding any further, again the same request, do like, share and subscribe my videos. Okay. So when we say indifference curve, first let's analyze this header. Curve means the graphical presentation, right? And indifference means it's made up of that curve, which is made up of all those points at which the consumer is, indifferent, neutral. He doesn't have any special inclination for any particular thing. For example, you ask me, banana or apple? I'll say anything will do, right? Your mother asks you, sabzi X or sabzi Y. You say anything will do, right? Or if you go out and just look for some hot beverage, so coffee or tea, anything will do, right? If cold beverage, okay, cola or Pepsi, both work or anything will work for me. So when you are showing that neutrality, that you do not have any inclination for any particular thing, right? So that bundle that is being talked about here in this chapter means this curve is made up of all those combination which give the consumer the same level of satisfaction. Okay, so let's understand more of it. When we talk about this indifference curve, so it's different from utility, how and why. In the previous chapter, we talked about cardinal aspect of utility, right? And cardinal measurement of utility assumes that we can measure the utility in cardinal numbers 1, 2, 3, 4. Means after having one apple, I got the satisfaction worth, say, 5 utils. This was the assumption of Marshall, the one who propounded this theory. But when we talk about this utility approach, this is given by Hicks, we call it Hicksian approach, right? He simply counteracted and said, how can you measure the utility from any consumption? You can maximum have the ranking done, like I'm happy with this, I'm sad with this, I find it good or bad, this gives me higher satisfaction or lower satisfaction. So he said that whenever we are talking about utility, utility is a relative aspect where you can just compare something with something in some subjective words. He said that cardinal measurement of utility is really not possible. It cannot be expressed that way. So this is the heart and soul of the whole chapter. Let's continue with IC approach now. So first and foremost thing is IC analysis is based on the following assumption that money income is this given and doesn't change. In the previous video, I talked about the budget line, right? What is budget line? We would have a great detail of this topic here in this ongoing chapter. It simply says that if M is the money with somebody, right? So the price of X and quantity of X, this product and the price of y into quantity of y, this product, this gives the expenditure on x and this gives the expenditure on y. So here it is assumed that the buyer is going for two goods x and y, and the product of these two means the expenditure done on x and y is equal to the money he carries in his pocket. So the first and foremost assumption is the money income is given to us and it doesn't change, right? The consumer spends his money on goods which can be substituted for each other, like apples and oranges. Means more of one would result in the less of other, but the things can be substituted for each other. Then you have the consumer preference for two goods is well defined, right? So this would be clear bit ahead. More of a good always gives more satisfaction to the consumer, and this is called monotonic preferences. This question is asked for 1 mark and it's just asked for its definition. What do you mean by the term monotonic preferences? And let me give you the same with the help of an example. Like it is given to you that a combination A gives you 2 and 3, means 2 units of X and 3 units of Y. And the combination, B gives you 3 and 5. So, being a rational consumer, what would you be going for? I hope you would say this. Why? Blindly, because you are getting more of X as well as Y. In some other instance, if A is given to be 2 and 3, right, and B is given to be 3 and 2, here we do not have any rule to apply because here we do not have any clear bargain, right? But here in this first case, we can clearly say that a consumer will be driven for set B, and this tendency on his part to have more and more is called monotonic preference. So he chooses that thing which gives him maximum satisfaction. Right. And the last is the consumer is rational. As I always say, rationality is such an assumption you can put in any chapter of the whole economics. Now, indifference set and indifference curve, right? So here it is assumed that a consumer is able to get only two goods. Here the goods are taken to be apples and oranges, right? So showing the combinations which he can buy with the money income which he has. So he can go for 1 unit of X and 10 units of Y, or 2 units of X and 7 units of Y, 3 units of X and 5 and 4 or 4. Right, you would be observing similar but just the opposite pattern which we studied in the first chapter, that if you are increasing some value, you have to reduce the other because the resources are scarce and limited. So as your money income is limited with you, so it simply says that you have to have lesser of one. You have to go for the sacrifice of one if you want to increase the other. Right? So these are the combinations. So when we are giving such a presentation that A combination says, you can write in this format also 1 and 10, 2 and 7. So this representation also is good to go for. So these are the indifference bundles, or we say indifference sets. And when we plot this on a piece of paper, right, this becomes the indifference curve. Now let's understand how do we make this curve. We have apples and oranges on x and y axis. As I always tell, that how do you decide which is going to be on the x axis and what is going to be on the y axis? The thing which is increasing would be on x, and the one which is losing would be on y. Because here we begin with the first combination when we have everything of y, most of the major combination is of y and least of x, and we gradually and slowly start increasing this. Right. So this is how indifference curve looks like. What do we call this shape? This is called convex shape. This is convex to the origin. Right. In the previous chapter of PPC, which shape did we study? We talked about concave shape. And I told you that whenever we're talking about shape, it has everything to do with the slope. And here the slope was called MRT. And how was it? It was increasing. So I hope you would be able to understand that here for convex shape, the slope would be decreasing. And what do we call the slope of IC, the indifference curve? It's called MRS, marginal rate of substitution. Means at which rate we are substituting good Y and X with each other so that we are having the best bargain, and we are satisfaction is exactly the same. It's just a matter of trade-off. I in my previous class also talked about trade-off. Trade-off means A and B, C, C, D, these are the points of trade-off. Means they are giving exactly the same satisfaction. It's just a matter of which thing would you have more and which thing would you have less. Right? And when these are lying on one single curve, it means all of these can be bought by the consumer with his present money income M. Right. So just something extra, that if his present income is this, and if he gets to have more income, so his IC would get shifted to right. And if he gets to have lesser than this income, so his IC would get down or towards left. Right? So the most important out of this diagram is, how do you say that the slope is decreasing? What do you mean by the term slope? Once again, the previous formula. What is slope? Slope is the rate of change of y with respect to x. So what is y doing? Y is getting the loss and x is getting the gain. So loss of y with respect to gain of x. And mind you, for all the chapters here in microeconomics, we introduce the term with m as the prefix. What is m? M is marginal. And when I say marginal, marginal means the additional unit. So additional unit means whenever one more unit of x is increased, we are trying to check how much of y is sacrificed. Right. On a similar note, if we are at B, so to increase one more, please pay attention that on X we are increasing the things marginally, but we are now observing for that marginal increase by 1 unit, how much is the loss suffered on Y. So first, the loss is everywhere the gain is 1 unit, 1 unit, and 1 unit, right? What's the loss? Loss is first 3. These are 3 units, then these are 2 units, and this is 1 unit. So point is, when we talk about this MRS, we have 3 is to 1, 2 is to 1, 1 is to 1. Means the loss of y is 3 and the gain of x is 1. Loss of y is 2 and the gain of x is 1. It means we have this trend of MRS. And what is this? This is falling or decreasing, right? And because of this decrease only, we get to have the convex shape. So after this discussion, let's understand what is indifference curve. It's a diagrammatic presentation of an indifference set of a consumer, right? A consumer has got a number of combinations for which he is just indifferent, right? It shows different combinations of two goods like apple and oranges here, right? Offering the same level of satisfaction to the consumer within the same money income, right? So again, the next topic is again very prospective, potential, and is expected in the papers. So these are the properties or the features of IC. IC means indifference curve. First, it slopes downwards. And we all know that whenever we're talking about downward slope, let's understand it by taking any 2 points of reference. So this is point of reference called A, right? If from A, somebody wants to go to B, what would he do? It means it is required to have a loss on y for any gain on x. So downward slope simply talks about the sacrifice, right? Let me just take up the words from here. He would have the sacrifice of one, right? It implies that consumer decides to have more of one, but he has to have the less of other. So there has to be a sacrifice involved for increase of the other thing. Now, here if we talk about the slope we have already defined slope is delta y by delta x, and if you just check out numerically in this given figure, what's the loss of y from 5 to 3, it has gone. So the loss is 2. And what's the gain of x? It has gone from 2 to 3. So it's 1. So the slope is 2. Okay. And why is it 2? No, we would say minus 2. Why minus 2? Because as given in the previous session also, that minus only is the symbolic of the inverse relationship or loss for a gain, right? The same concept you would have in demand analysis as well. Then second is IC is convex to origin, and I did tell you whenever you're talking about shape, you talk about slope. Or whenever slope is being asked, you talk about shape. This is how we justify it for the reasoning part. Why it has got convex shape? Because of its decreasing slope. Right. Then if the question is what is the implication of decreasing slope? It would have a convex shape. And this has already been told, and let me show it once again to you, that if I'm just increasing marginally, right? See, IC looks like this. Try and understand. And apologies in advance for the wavy lines. what does this convex shape give you? It talks about the sacrifice for the gain of x. So, do you understand that when I'm making this shape, the sacrifice is decreasing? At first stage, this is this much. Then at second stage, it is lesser, and third stage it is all the more less. So, this clearly shows that convex shape means the decreasing sacrifice. Right? Here also, they have talked about the diminishing MRS. I told you what is MRS. MRS is the name of the slope given to IC. So, how do we measure it? There is 1.5 units. See, 1.5 units with respect to 1 unit of increase. Here it is from this to this, from 3 to 5 again, 1.5 with respect to 2. So this is the justification of convex shape. Okay, and what's the answer? Answer, you would see that MRS is minus 1.5 followed by 0.75 followed by 0.25. So we just see exactly the same result once again, that IC is convex because the slope keeps on decreasing. Then, this is a beautiful property. Simple and easy to understand. Higher curve gives higher satisfaction. You may take any point anywhere. If you want to take it here, if you want to take it here, you just see. This is giving me this combination of y and x. But if I'm taking this point on the higher IC, so what do I get? I would have definitely extra either on x or on y or on both. So I have this much extra of y and this much extra of x, right? And this higher combination, if we are comparing it, so we are getting more of x, but it's all the way more. Point is, you may just give any type of expression. You may take two points on straight line also. You will show that compared to A and B, B is giving this much of extra of x, keeping y constant. Right. You may take these 2 points also, wherein you are taking it vertically. So you'll show that this much of extra is given by the higher IC, right? Keeping the other constant. And if you want to show it at a random expression, so you'll show that, yeah, extra of both is seen here. So higher IC always gives you higher satisfaction. Means more of goods would be received. This question show that higher IC gives higher satisfaction is clearly, as I have explained, that R point and S point are lying on two different ICs. S is lying on higher IC and S is giving this much higher of X, keeping Y constant. So it's proved. Right. This is again a beautiful property of IC and which is most often asked in the examination. Let me explain the same through my own diagram. ICs do not intersect each other. So, on the contrary, we are assuming that these are intersecting each other, right? So, let's explain. IC1 and IC2 are intersecting at point A. Take any other 2 points B and C on both the ICs, right? So just check. From IC1, we say that the satisfaction given by A is equal to the satisfaction given by B. Why? Because all the points of one IC give you the same satisfaction, right? And then we would explain it as because A and B are lying on IC1. Okay. Now, A point also gives the same satisfaction as C point because A and C are lying on IC2 and all the points of one single IC give you the same satisfaction. And mathematics say if A is equal to B and A is equal to C, what does it mean? It means B is equal to C. Now, please check. B gives me this much of x and this much of y. But C gives me the same of x but higher of y. Can this be possible? Is it possible at all that this and this is equal. No, they are not coinciding. C is giving us more of Y. So it is giving us more of satisfaction. Hence, our supposition is wrong, and hence two ICs can never meet each other or intersect each other. So they have taken points B and C here, and they have taken point A here. So they want to show that A and B are equal and A and C are equal, but B and C can never be equal because C is giving you this much extra of X. Fine. Now let's proceed. Another property that IC doesn't touch X and Y axis, it's very simple that the moment it touches X or Y axis, it becomes a single commodity case, right? Here, the combination of Y is there, but X is 0. 0 and something is there. But here, something and 0 is there. But we already assume that IC is an analysis of two goods, not one. So two ICs would never intersect each other and neither they would touch the axis. For now, we close the session here. Next topic would be the budget line. That's again interesting. Stay tuned. Do let me know your queries and feedback. Goodbye. See ya.